Hi, everyone. I wanted to start this with this nice little Google Doodle for today. This is a tribute to public health workers and to researchers in the scientific community. Thank you. And I love the fact that there are a couple of bell curves up there. All right. Speaking of bell curves, the standard normal distribution, the most basic of bell curves. Remember that the standard normal distribution is the most basic normal distribution, with mean 0 and standard deviation 1. Again, mean 0 over here, this mean line corresponding to this hilltop, and standard deviation 1, the distance between the mean line and either inflection point by symmetry. Now, the formula for this curve is given by this, but we don't worry about that. Don't worry, you won't have to use this. We're going to work with probabilities because we really care about areas. We don't care so much about y-coordinates. We care about areas, and those correspond to probabilities. Now, on the homework, I will give you hints, but you might be curious where these hints come from. For example, you might be curious in doing your own statistics. So I'll show you some online software, free online programs, and how you can use software like Excel to find out these hints. All right, so let's say that in example 1, software tells you that this probability, the probability that a standard normal random z, random variable, is less than negative 1.24, that this probability is about 0.1075. First of all, I want to show you a picture of what this means, and then show you how online programs and software can discover this hint for you. First of all, part A, sketch a figure clearly showing this fact and shade in the relevant region. All right, so I do want you to draw these kinds of basic pictures. And here is what I'd want you to do. Okay, so first of all, make sure that the negative 1.24 on the z-scale over here, all right, let me do this. The negative 1.24, okay, is to the left of 0. All right, so remember that the 0 is over here. Here's 0, corresponding to the mean line. At the very least, in addition to drawing a decent bell curve, please make sure that the negative 1.24 is to the left of 0. Now, the inflection point here does correspond to negative 1, but don't worry about that as much. The main thing is I want you to show that negative 1.24 is to the left of 0. Okay. We're concerned about the probability that z is less than negative 1.24. This means that we're concerned about this area to the left of negative 1.24, because this corresponds to a left-tailed probability. And the software is telling us that this is about 0.1075. So I put the 0.1075 here, put an arrow here clearly indicating that I mean the area of this region, and that's that. Okay, we've answered part A. Sketch a figure clearly showing this fact and shade in the relevant region. This left-tail probability is about 10.75%. Now, you might be curious how you can get this information from free online software. Well, I'll show you. The probability that z is less than negative 1.24. How did we do this in the olden days? This is ztable.com, very appropriately named. And this basically gives us a table, which used to be in the old school textbooks. The textbooks still have these, where on an exam, students might be asked to pull these out and work with these tables, these print tables. And these z-tables would tell us these cumulative left-tail probabilities. So part A here was very well suited for that kind of issue, because this dealt with a left-tail probability, the probability that z was less than negative 1.24. Okay, so the z-table gives you the probabilities that are these left-tail probabilities, these cumulative probabilities for a given z-score. Remember, we're curious about the case where the z-score here is negative 1.24, and we want to know this probability or area here. All right, well, in the left column, you look for negative 1.2, the integer part, and the tenths place, negative 1.2. And then for the hundredths place, you would look up north, up here, and here you have the 0.04. So here we have negative 1.24, okay? And you look inside, outward in. Negative 1.24. Don't you miss the olden days? All right, and look at this corresponding probability or area, 0.1075. So we're making the claim that this left tail probability here is 0.1075. All right, I'll go ahead and erase these marks, by the way. I need the eraser here. Okay, so erase this. Now, aside from tables, there are other ways you can find these things out. StatTrak, the normal distribution calculator. All right, standard score. Let's put in negative, let's put in negative, blow this up, negative 1.24. All right. Okay, I pressed return. Okay, 0.107. All right, well, pretty close. We got 0.1075 over here. All right, but this is saying 0.107. All right, and again, this corresponds to a standard distribution. Standard normal distribution, mean zero, standard dev 1. Okay. Also on my website, in the middle here, statistical calculators. Let's see, this is tutorhomework.com. Standard normal distribution. Again, if you're looking for a left tail probability, all right. Okay, so we give it a z-value, negative 1.24. Click on this arrow, the probability we get, 0.1075, which verifies what we had in our table here. I've been skipping over the Excel spreadsheet here. I'll explain this. By the way, I didn't mention this before. Here's how you can generate some standard normal random variables. Norm.s.inv rand. It's a little complicated, but that's how you can get a standard normal 0-1 random variable. Okay, but I wanted to talk about this over here. Okay, so again, what's the probability that z is less than negative 1.24? All right, so it's the norm.dist command, normal distribution, negative 1.24. I'm interested in the left or cumulative probability for that z-score. Okay, I have the 0 and the 1 here because I'm dealing with a standard normal distribution. Okay, so I want mean 0, standard dev 1. And I put true here because I want a cumulative or left tail probability. If I put false, then I'm looking for the y-coordinate of that point there on the curve, and I don't care about that. So I put true here, never false. Okay, so if I do that, equals norm.dist, negative 1.24, 0, 1, true, right? So a 0.1075 roughly. All right, and that gives me the left tail probability. Okay, so basically I've been showing you a bunch of ways that you can figure out this hint. The picture, of course, was really critical here. First of all, to figure out what even the heck we were doing, right? But then we're going to use this picture to answer the other questions in example 1 in the next video.